Hello and welcome. My name is Jan Poeschko. I lead the cloud engineering team at Wolfram Research, and today I want to talk about what's new in the world of the cloud. So to get started, let me give you a quick introduction to the cloud in general. The idea is basically that we bring the full power of Mathematica and the Wolfram language to the web, so that you can work with notebooks and write Wolfram language code right in a web browser without installing any local software or even any browser plugin. You can then take your interactive notebooks that you've created in the cloud or also on desktop and share them with other people. And it allows you to deploy whole web applications written in Wolfram language to the web and make them available to the world. So let's take a closer look at the notebook interface in the cloud. And by the way, this is running in a web browser right now. So this is Chrome with a cloud notebook that just happens to be in slideshow mode. That's why it looks a little different. But otherwise, this is a regular notebook where you can edit things and evaluate cells like this here. And in this case, you get back a long result that's all rendered in your web browser using our JavaScript frontend. You can use the predictive interface to keep going with your computation. And of course, you can use manipulate, like on desktop, that provides an interactive interface where you can drag sliders and use other controls to manipulate your output. And you can use a function called Cloud Publish to publish stuff to the cloud. In this case, we take the manipulate from before and give it a certain name. And that gives me a cloud object, which is basically a handle to a file in the cloud. And you can click that link, which opens that manipulate in a standalone deployed view that I could now hand to other people, and they could open that at this URL. So as you can see here, we can render pretty much any output in Cloud Notebooks. It's a bit more challenging when it comes to editing things. So what we don't support yet, unfortunately, is editing things like fractions and tables directly in Cloud Notebooks. But there are a couple of things to work around that and new features that we've added to make it a little easier to edit even math expressions in Cloud Notebooks. And one new thing, for instance, is tech input. So I can now press Control-4, where also the $sign is on the keyboard, to get back this little control where I can now enter tech code. For instance, fraction of x over y. And when I press enter, it will resolve to the typeset expression corresponding to the tech input. In this case, this is still an input cell, so I can even do computations around that, and it will have the right semantic meaning as well. Similar feature that already existed before, but just as a reminder, is input form-based input, which I get through Control-Shift-1. It looks very similar, just that here I'm entering input form. So for a fraction, that would just be x/y, and now this resolves to this fraction. And also similar on the cell level is convert to standard form and the other way around. So I can also type x over y like this, and then press Control-Shift-N, and it will turn to the standard form rendering of this fraction. If I want to go back, it's Control-Shift-I for input form, and now I'm back to this code. Another new feature in the world of Cloud Notebooks and editing them is a new hyperlink user interface. So if I have some anchor text like here, I can now press Command-Shift-H on Mac. That brings up this little popover where I can enter a URL or also browse for the cloud objects and various things to enter a hyperlink. And it's just a little nicer user interface than it was before to work with hyperlinks. By default now, also hyperlinks will always open in a new tab, but as you saw in the little popover, I can change that to not open in a new browser tab if I wanted to. Another big area we're working on in Cloud Notebooks is what we call the native graphics project, where the goal is that we render graphics right in the JavaScript front end without any further interaction with the server-side kernel and the front-end process there. Because in general, what we do is we use the front-end process running on the server to generate some JSON helper data that then the client can turn into an SVG graphic. But that always comes with a little overhead, and on the one hand slows down rendering of graphics a little bit and also prevents certain features like dynamics from working in graphics. But with the native implementation of graphics in the JavaScript front end, that will change. So these are just some examples for things that can already be rendered natively in the JavaScript front end. And it will also allow things like this animation here to run entirely on the client side without any server interaction, and that's what makes it smoother. There is a related talk about this by Matt and John tomorrow that you should definitely watch if you're interested in more of that and the whole background behind it. But for now, I'll keep going. And another thing that's new in Cloud Notebooks is support for video. So you can evaluate a video expression like this, and then you get back a video player right in your Cloud Notebook where you can, of course, play that video. It's also fully supported in the Cloud kernel. So if you ask for information of that video object, for instance, you get back this result. And you could, do things like extracting frames or concatenating videos in Cloud kernels. One thing to keep in mind is that videos are supported based on URLs. So if there's a public URL where the video is hosted, you can just feed that into video and it will be rendered in the cloud. Or if they happen to be at a cloud object in your cloud account. So to do something like that, I just copy the file from that URL to a cloud object in my account, and already exists, so I have to tell it to override it, and then I can create a video based on this cloud object. If you want to learn more about video functionality in the Wolfram language, then there are other talks by Shadi and Carlo at this conference that you might be interested in. So another thing that's new in the cloud is support for system modeling. So you can, for instance, create a model based on some example data. So then we can ask for the summary of that model, for instance, and run simulations on it. So in this case, we just insert a certain value and then we run a simulation. And then finally, we can plot the outcome, of course. I'm not an expert in system modeling, so can't explain you too much of what's going on here, but there are definitely other talks by Jan and others who will talk more about System Modeler. The challenge here was basically to support running of the simulations in the cloud in a secure way that doesn't break our sandbox assumptions. But that's all working now. Another thing we've been working on recently is a new implementation of Cloud Expression. So with Cloud Expression, the idea is that you can take an arbitrary Wolfram language expression and store it in the cloud, in this case with a given name. And then I can make updates to it, like appending something to this list. I can also extract individual parts from that list, or also get back the whole thing at once. But the point of Cloud Expression is that you can make efficient granular updates, and also you can extract things efficiently. So this does not have to download the whole expression at once just to extract that part. And also when I'm appending something, I'm only sending this new part to the server and not, getting the whole expression and then adding the part and then sending back the whole thing like you would do with Cloud Put and Cloud Get, perhaps. So it's a very efficient way to work with expressions and update them in a granular way. And moreover, this happens in an atomic way. So there's a guarantee that, let's say, if you increment a number in a cloud expression and that happens concurrently in several processes, that there is no conflict between them. There's no race condition where, two updates would happen at the same time and then only one of them would actually take effect. So it's an atomic guarantee that's very nice for certain applications. And the new thing is that this is backed by a Postgres database now in the cloud, as opposed to the in-memory Redis database that was used before. And that means that it's really ready for prime time use now and not experimental anymore. That will of course be reflected in the documentation, where you'll find all sorts of information about Cloud Expression. And if you've used Cloud Expression before, while it was still marked experimental, and you want to make sure that your data is migrated properly to the new system, then please make sure to read that update announcement on Wolfram community. Now, switching back to the topic of cloud notebooks, one thing I want to talk about is embedding notebooks and also external notebooks, which is a new feature that we've implemented recently. So there's already been this notebook embedder library, which is very useful, I think, to basically embed notebooks on arbitrary websites. You can check out the website of that embedder library. The idea is basically that you have some container element on your website, and then with a bit of JavaScript code, you can embed an arbitrary cloud notebook on your website and also interact with it through JavaScript code, like let's say open and close cell groups, or change the values of certain variables in your dynamic module, or manipulate. And all of that happens in a very seamless way, where, for instance, the size of that container is adapted to the content of the notebook. So that's a very useful library. And what we've added now recently is a support for external notebooks, as we call them. Notebooks that are given by a URL, sitting somewhere at a public location on the internet, or even by a notebook expression that you just provide on the fly, as opposed to notebooks that are already stored in cloud objects in the Wolfram Cloud. So in a standalone form, you can just construct a certain URL, like here, wolframcloud.com/view, and then $URL equals something. And this immediately gives you a view of that notebook rendered in the cloud, even though there is no cloud object backing that notebook at this time. So this is a fully functional notebook that others can look at. Let's say if you have, like in this case, a notebook hosted on some website, that can be useful. Or also if your notebook is, let's say, on GitHub, you can just use the GitHub URL that serves the raw notebook file and then plug that into this API to view the notebook. And similarly here, we have an API that renders a notebook given just a notebook expression, a very simple hello world cell. The only thing to watch out for here is that the characters in the notebook expression need to be properly escaped or percent encoded in the URL. And what's also cool is that this also works in the Wolfram Notebook Embedder library. So instead of providing a cloud object URL like here, you can now provide the cloud base, which also defaults to wolframcloud.com, but just in case you want to point it to a different cloud, like your enterprise private cloud, for instance, you can do that with this cloud base parameter. And then you specify the URL of the notebook you want to embed. In this case, that's actually a GitHub URL. And something similar would work for a notebook expression. So instead of URL, you would just have expr here, and then you would provide the expression in input form. So that could be useful, for instance, when you have your website and in some JavaScript code, you might even construct a notebook on the fly and then feed that into the embedder library to render it on your website. Speaking of documentation, one thing that people were sometimes wondering is, how do I know whether something is currently supported in the cloud or not? Because while most of the core functions are absolutely supported in cloud kernels, there are some Wolfram language symbols that might not be implemented yet for technical reasons, because maybe there's some technical challenge that we haven't solved yet, or maybe we have to disable them for security reasons, because in the cloud we need to provide a certain sandbox that user code runs in. And we're finally able to answer that question in a better way now, because what we did is we hooked this up in Wolfram language data. So you can now ask Wolfram language data for the cloud support status of a given symbol. So for instance, for plot, it will say that it's supported. But then for other functions such as run process, it might say that it's restricted in public cloud because you can't actually run arbitrary processes in the public Wolfram cloud. And then you can also ask for cloud support nodes, which gives a bit more detail. In this case, it says it can actually work in an EPC, it's the enterprise private cloud, if the sandbox is disabled there. So that gives you a better idea what to expect when you use a certain function and whether it can be expected to work in the cloud or not. And this will also be included in the documentation. So in the upcoming version, you'll see, for instance, for run process, a little text here on the documentation page that says restricted in public cloud. This cloud support status is mainly focused on the kernel side of things. So we describe whether the evaluation semantics of a given function are the same in cloud as they are on desktop. Whereas if you're more concerned about particular notebook features and how things are rendered in the end, then we have this implementation notes notebook that describes a lot of the things that go on under the hood in cloud notebooks and also some of the restrictions that result from that. So this is a good source of information for now, and we're also working on incorporating that into the main documentation. And then another source of useful information is usually the cloud release notes. So at this location, we add a new notebook for every major release that we make of the cloud, and so you can stay up to date of what's new, what's happening, and if there's any major changes that might affect your code in the cloud. And finally, another major project we're actively working on right now is the containerization of the whole cloud architecture. So the idea here is that we split up the big cloud application into different services that can be scaled up and down individually and that are isolated from each other to some degree. It's technically not fully correct, but you can think of these containers as a bit like very lightweight VMs. It's not a microservices architecture, if you've heard that buzzword before, which I think is often a bit of overkill, but it introduces service boundaries where it really makes sense. And one particularly interesting user benefit from this will be that kernels will run in their own containers. So at every point in time, a user evaluation will run in its own container, isolated from the rest of the cloud application. And that means that in the end, we'll probably be able to lift that restriction, for instance, about run process that I mentioned before. So we'll be able to run processes and also libraries provided by users in the public Wolfram cloud without sacrificing security. And where this will be even more interesting is enterprise private cloud. So for instance, it will make it easier to add more kernels to your EPC on the fly and to make things like the database and the static file server more robust and more redundant. And in general, it will bring the architecture of EPC much closer to the architecture that we're using in the public cloud on wolframcloud.com. So what this will mean is that EPC will be shipped as a so-called Helm chart and corresponding container images. And then it will run on Kubernetes, whether that's the Amazon Kubernetes service or Azure or your on-premises Kubernetes cluster or really any other Kubernetes environment. But it will also be packaged up as a proper virtual machine if that's what you desire instead. So overall, it will make it much easier and straightforward to spin up an EPC, but it will also make it more powerful. Of course, there are many other things we've been working on over the last year or so. So just to mention a few briefly, we're constantly working on performance improvements, and also accessibility has become a focus for us. And we've added a way to protect against spam in form function. So check out form protection method if you're interested in that. We've added support for single sign-on in cloud. So if you have an organization with your own user management, like at a university, that could be interesting. And finally, I should mention that because we need to be a bit careful with our storage, we're now enforcing a certain expiration for files if you only have a free Cloud Basic account. So if you want to keep your notebooks and other cloud objects for longer, please upgrade to a paid subscription. In summary, some of the things I've talked about today are the new tech input, the new hyperlink UI, native graphics. Definitely check out the other talk by John and Matt about graphics in the cloud if you're more interested in that. Then I talked about support for video, system modeling, and the new cloud expression implementation in the cloud. We talked about external notebooks based on URLs and expressions that you can render directly in a standalone cloud view or using the Wolfram Notebook Embedder library. Then I showed you Wolfram language data and its new cloud support status property. And finally, we talked about the new upcoming containerized architecture of the whole cloud that we're working on.